So today I'm bringing a little bit of a different problem. I'm doing an engineering statics problem. Um, it's I'd say a beginning of the semester type of problem, not necessarily an easy one, especially if you're still not familiar with some of the statics concepts. So let's get to it. So the first thing to do on those type of problems is to read the question carefully. So find the stretch length of spring AC, which is this right here, if force 80, which is P right there, causes the angle theta equals 60 for equilibrium. Okay. Chord AB is 2 feet long and the spring constant K is equal to 50 pounds per feet. Okay, so they gave us that this right here is 2 feet, right? And they also told us the spring constant K. All right, so obviously I know how to solve this problem because I have some experience. But if you don't have experience, that's okay. You'll get there. But the idea here is just to show you some tricks just to get you on the mindset of how you should approach a problem like that, right? So the first thing that I would do is just draw a free body diagram. Just because it allows you to immerse yourself in the problem and, try to get a sense of what really is going on. Okay, so we have a chord going here. Then we have point A, which is like kind of like a point of interest for us, right? This particular part of the class deals with uh, particles in equilibrium, so that's kind of the idea why A is so important. And then we have the spring there, and obviously, if I were to complete this, right, which is not completed like physically, these two are attached on the side, right? This would give me a total of 4 feet, right? And obviously I have an angle of 60, and then I also have the force here, and then I also have 2 feet here, okay? So the reason why you draw the free body diagram is because you're trying to get rid of as much noise as you can. I mean, the problem has a lot of noise, right? Like the picture. So now, I mean, look at this. This is a triangle, right? So that triangle may or may not give us some sort of information. It turns out that it will give us a lot of valuable information. So before we even do that, let's just figure out what the problem really wants so we can laser focus and not waste time. So find is right here. Unstretched length of spring AC. Unstretched length, I'm going to call it X naught. In other words, X initial, when the spring is not under any type of compressive or tensile load. So we're looking for X naught, which means that we, at some point, are going to have to figure out what the force of the spring is, okay? And the force of the spring, if you remember, is K times delta X, or, okay, K times, I'm going to break it up to make it easier for us, XF minus X naught, okay? So if we get the force of the spring, okay, we already have K, and if we get XF, we can find what the problem wants, which is X naught, okay? So Fs we're going to find from statics, okay? That's the only way that we can find it. K is given, okay? And XF we're going to find through the geometry. I'm going to abbreviate there. All right, so that's why I said that the triangle could be very valuable, and it truly is. So let me draw it one more time, okay? Because this right here is XF, okay? This is 2, this is 4, and this is 60, okay? So to find this side, we're going to use law of cosines. I mean, that's basically the quickest way that I can think that we should be able to do it, which says that the side that's opposite to the angle that you're given, 60 in our case, is equals to, squared is equals to a squared, which is the other side, plus b squared, another side, minus 2 times ab, both sides, cosine of that angle that's given. Okay, so we have xf is equals to the square root, right? I'm just kind of solving real quick. 2 squared plus 4 squared minus 2 times 4, just filling in the blanket, right? Cosine of 60. So if I plug this in on my calculator, let me see what I get. So square root 4 plus 16 minus 16 times cosine 60. All right, 2 square root of 3. 2 square root of 3 feet. So we got XF, all right? Check, check. Check, check for K. We're looking for Fs, all right? Let me change colors now. So we're looking for Fs. Fs, we're going to get it with statics. So this is the statics part of the problem. So we're going to analyze A in equilibrium, okay? I'm going to say that X is to the right, positive, and Y is positive up, okay? So imagine like a coordinate system here at A. We have the force of the spring pulling us that way. The force of that cord goes that way. And P goes down, okay? It's given as going down. Now, let me just say something, okay? Because a lot of you are probably asking yourselves, like, how does he know that the forces are going that way? Well, like I said, I do have experience with these problems, and I also have built some sort of intuition. But one thing I'll tell you for sure, one of these forces, Fc, which is the case, Fc, it can only go this way, okay? Why? Because it's a cord, right? A cord is always in tension. So when I say tension, is a cord is always pulling something, right? Cord is always pulling something. So that something in our case is point A, okay? Now Fs, I mean, it's a spring. It could have been in compression or tension, which is the same thing as what the cord is doing, pulling it. But in that case, I know that it's going that way, so I'm going to save us a little bit of trouble. But let's just suppose, just real quick, we had said that, different color. Let's just suppose that I had guessed that Fs was going that way. Okay, I had guessed that it was going to go that way. Or I should say, why am I pointing out this way? Like inwards, okay? Let's just say, I would guess Fs is going that way, pushing us in. That's okay, because the math would later on tell us that this Fs that we suppose to be that way would just be negative of something, right? It would be a negative value, which means we guessed the wrong direction. So in that case, you can actually guess. But for the cord, you have to draw it in tension, otherwise you're not going to be able to solve the problem, okay? It's just a conceptual thing that you have to know, and you get that the more problems you do and the harder you think about these, okay? So now, to solve the statics, what we're going to do is just draw the equations of equilibrium, right? So we have sum of the forces in the x, positive to the right, is equals to 0. I'm going to label some random angles here because they're going to help us. I'm going to call this alpha, and I'm going to call this beta, okay? So, Fs cosine alpha, so Fs goes this way. Then we have the component that we're looking at, which is going to the right. Right? So Fs cosine alpha, so we're looking at this. Should have done it a little bit better. But we're looking at the component that's going to the right. I just wanted to do a squiggly thing. Okay? So it goes to the right, and then similarly we have, in a different color, alright, Fc has also two components, right? You can break it up and it's still the same thing. You just don't account for this anymore once you break it out, okay? So this won't be, the vector itself won't be accounted for once you break it up, okay? Because it's the same effect, but you're choosing to break it up, so you have to stick to, it broken up. So Fs cosine alpha, and then I call the other one beta, so it's minus Fc cosine beta is equals to 0, okay? So why is it minus? Because it's going in the opposite direction that we defined, okay? We defined positive to the right. All right, nothing else going in the x direction, okay, guys? So this is it for fx. Let me just do fy real quick, because then we're going to jump into just a little bit more geometry. I mean, I need to know these angles, right? And I'm going to have to figure out some sort of geometry there. So Fs, then we have going down minus 80. So sum of the force in the y, minus 80 going down. Plus, okay, so now let me just change colors real quick. I'm looking at this component. I'm going to look at this component. They're both going up, okay? They're both going up. So FC sine, because it's the opposite to the angle, sine of alpha, right? Did I do this right? No, it's beta. Okay, so FC is the angle is beta. All right, beta plus Fs, which is also going up, sine of alpha. Now it's alpha. Awesome. Equals to 0. All right. So these are the two equations that will allow us to solve. So we'll find Fs. And once we find Fs, we're done. We'll be able to finish the problem. All right. So to get those angles, right? To get those angles, I should probably refer back to the initial geometry that I was given, right? So follow me real quick here. I'm all the way up here on the top left. Okay, so on the top left, we have this overall geometry, which, let me just erase this, because I wrote it too big. Let me erase this, and then I'll write it again. If I break this triangle into two by making a perpendicular line there, okay, I know this side, which is 2 feet. I know this side, and then I know this angle, which is 60 degrees, okay? So that allows me to either just, well, actually, I take it back. This side is not part of that triangle I just built. Look, I just confused myself. I was looking at this triangle. So 2 is all the way here. Nope, I do not know that side, okay? I do not know it. So we have 2, that's guaranteed. That's this side, side AB. And then I'm gonna conveniently just find this right here. Well, I probably should find both. So let me find both. Why not? All right, I'm gonna use it later anyways. Or perhaps, well, let me think about it. Let me think about this. All right, let's just do the completion thing. All right, so let's just find that angle. So this angle, the side, sorry. So the side here is, going to be, if I do it on the side here, 2 sine of 60, okay, and that is equal to, sine of 60 is square root of 3 over 2, so 2 square root of 3 over 2, so this is just going to be square root of 3. So this is square root of 3, and this right here is cosine, so 2 cosine 60, which is just, 1/2. So 2 times 1/2 equals to 1, right? 1. Awesome. So I have that one. And then I already know this side here, which I calculated as xf, which is 2 square root of 3. So we should also be good on that, okay? I'll show you guys why I want those ratios, because they'll make my approach so much easier. Okay, so if I scroll down real quick, I have 1 square root of 3. Alright, so if I build that same triangle here, right, I had 2 here, and I have 2 square root of 3 here, okay? This corresponds to the geometry that's in the problem, like this side here is, remember, it's kind of like that geometry. And then here is just what I calculated. Let me highlight it. So this right here, okay, if you just flip that triangle upside down, it's this side, okay? So that will be what I calculated as, if I'm not mistaken, it was 1. And this was 2, or should I say square root of 3? Yep, so 1 and square root of 3. So the height was square root of 3. My mistake, I'm sorry. The height was square root of 3. And then right here, same thing applies, square root of 3, because it's a the same triangle, the same side here is being used by this other triangle, okay, which we're going to use for the ratios. And I should probably get this side then, right? I didn't get that. Okay, so this real quick, if this is by Pythagorean theorem, I can solve that real quick. That will be square root of, let me just erase that. Sorry. So to get this side here, thinking that this is a right triangle, we're going to get 2 square root of 3. Terrible handwriting. minus square root of 3 squared. So that gives us the side that we're looking for. So let me just punch this into my calculator real fast. That gives us 12 minus 3 square root of that. That's 3. Okay. Let me just double check to see if I got it right. 12 minus 3. Yeah, and then square root. That makes sense. All right, so that's 3. 3 and then square root of 3. Boom. And then this was, square root of 3 and then 3. Awesome. All right. All right, so now that we have that, all we have to do is just follow the triangles, right? And then just, substitute these trigs, the trigonometry here to their ratio of the sides, all right? So we have Fs cosine alpha is going to be adjacent over hypotenuse. So adjacent over hypotenuse. So 3 over 2 square root of 3, okay? Minus, well, let me move it to the other side. Fc cosine beta is going to be adjacent over hypotenuse, 1 over 2, right? And then I'm going to conveniently solve for Fc. Why? You see it in a second. Fs. And then once I do that, I'm done with this part. So the same two equations. Then I have Fc, which was, well, now let me label these just so you can follow it a little bit better. We have Fc sine of beta. Sine of beta is just opposite over hypotenuse. So square root of 3 over 2. And then I'm right here, okay? Fc sine beta plus Fs sine alpha. Sine alpha is just opposite over hypotenuse. So square root of 3 over 2 square root of 3. These are going to cancel. I'm going to cancel them already. And just double check my work. Yep, that makes sense. Let me highlight it so you see. Okay, square root of 3, 2 square root of 3. Awesome stuff. Equals to 80. I'm going to move the 80 to the other side. So now this is when this little substitution I did ahead of time comes in handy, because I can just take this, place it right here, okay? And by doing so, I can solve for Fs, okay? So let me change colors one more time. Let me go with like something completely different. So I have 6, 2 square root of 3, Fs times square root of 3 over 2. These are going to cancel. Plus Fs 1 over 2 is equals to 80. If I find Fs, if I solve for Fs, I'm going to get 3 over 2, 3 over 2 plus 1/2. And that's 2. So 2 Fs equals to 80. So Fs is equals to 40 pounds. Awesome. Took us a little bit, but we got there. And then finally, remember, our goal, it's been such a long time, it's crazy. Our goal was to find what the initial size of that spring was. So x naught, we were looking for x naught. So F spring is equals to K times xf minus x naught. This is in parentheses. So we have that 40 is equals to, I think this was 50. Xf was 2 square root of 3 minus x naught. Awesome. Easy enough. So 40 over 50 minus 2 square root of 3 equals minus x naught. So x naught is going to be, let me just do it real quick. Sorry, completely unprepared, but that's fine. That's the good stuff. All right, looks like we got it. 2.66 feet. X naught. That's it, guys. That's it. Awesome. Thank you, and please let me know if you found this helpful, and give me suggestions of what you want me to do next. Thank you guys.